Hey geometry students, what we're going to be doing today is section 2.6. We're going to prove statements about segments and angles. Our objectives are learn how to prove statements about segments and angles and apply postulates, definitions, and properties to our proofs. Okay, let's get started. Before we get started, actually, I'm going to tell you we are splitting this section up into 2 days. So this is going to be part 1 of our section 6, okay? Alright, so now what we're going to look at here is this is how we set up our algebraic proofs, and this is how we're going to set up our geometric proofs also, is into 2 columns. One for equations, one for reasons, and for geometric proofs, we're going to call our first column statements rather than equations. Okay, so in our 2-column proofs, we have numbered statements and corresponding reasons that show an argument in logical order. Reasons used in a proof can include definitions, properties, postulates, and theorems. Some definitions that we have learned so far that we can include in our reasons are maybe something like definition of midpoint, or definition of perpendicular, or definition of bisector. And that's what we're going to state also, is definition of, and then the word that we need of our definition that we are looking at. Definition of congruent segments or congruent angles. Okay. Properties that we have learned are addition, subtraction, let's see, what else have we learned? Division, multiplication, distributive, and let me think of some others, some distributive, let's see, reflexive properties, symmetric property, transitive property. All of those properties also would be included into our reasons for in a 2-column proof. And some postulates, any of the point line plane postulates that we have looked at, and also the angle addition postulate, and also the segment addition postulate. We can use those as reasons in our proofs. Okay. And then for theorems here, once you have proved a theorem, you can use it as a reason in other proofs. So once we find a theorem and we've either proved them or the book has proved them that we've seen, we can use those in our reasons in our proofs. Okay. We have properties of equality, which also coincide with properties of congruence. So here's all of our properties of congruence using the reflexive, symmetric, and transitive properties. So congruence of segments, this is what it's going to look like. We're going to have, if AB exists, then AB is congruent to AB, or segment AB is congruent to segment AB. Okay, and we have to write it just like this. Segment AB, put the bar over the letters, or else that's just stating a length, and that's a variable, remember from the last section. And then we're not going to say segment AB is equal to segment AB. We're going to have this symbol, congruent, okay? Just like with all the others, we're going to be using congruence throughout, because these are properties of congruence. All right, let's look at congruence of angles. So if angle A exists, then angle A is congruent to angle A. So just note that reflexive property is the redundant property, okay? It likes to restate itself. Symmetric property is this right here. If AB, or segment AB, is congruent to segment BC, then segment BC is congruent to segment AB. So just know that symmetric property is kind of just a mirror image. It is flipping things across the congruent symbol. Same thing goes with angles. So angle AB is congruent to angle AB, then angle B is congruent to angle A. And then the transitive property. Remember, the transitive property is the property where it cuts out the middleman. So segment AB is congruent to segment BC, and BC is congruent, I should have written congruent right there, congruent to CD. Then, like I said, we're cutting out the middleman right here. These BCs right here, we don't have to state them over again. We just know AB is congruent to CD, these two segments on the end here. All right, same thing goes with the angle, congruence of angles for the transitive property. Angle A is congruent to angle B, and angle B is congruent to angle C. Then angle A is congruent to angle C. We'll use that quite often in our proofs, actually. So please remember these proofs right here, or these properties. And I'm going to say especially note this reflexive property and transitive property. You wouldn't think we'd use the reflexive property very much, but we will. Okay, let's just look, remembering what we just looked at. So reflexive property of congruence, here's how we would state it here, is if we're going to fill in the blank, and this is angle 4 over here, well, reflexive property is the redundant one, so this is angle 4 over here. Symmetric property of congruence, if we have this is our then statement, remember, flip them. And that's going to be our if statement. Okay. Exercise 6 through 9 says name the property illustrated by the statement. Okay. So if angle 1 is congruent to angle 2 and 2 is congruent to angle 4, then angle 1 is congruent to angle 4. Remember, we're cutting out the middleman here. So that is the transitive property. Okay. And 7, xy is congruent to xy. It's redundant, so that's the reflexive. And then 8, let's look at it. It says if angle CDE is congruent to RST, then RST is congruent to CDE. See that these two angles are being reversed. So that is going to be our symmetric property. All right, last one, 9. If segment AB is congruent to segment BC, right here, then segment BC is congruent to segment AB. Again, just like number 8, except using segments. We are flipping those segments around and stating they're congruent, so symmetric property again. Alright, let's get started on a proof. This one is actually not so bad. This is just 3, maybe 4 steps. that we're going to use in showing our proof here. So it states here, our given information is angle A, measurement of angle A is equal to the measurement of angle B, and the measurement of angle B is equal to the measurement of angle C. So that's our given information. So first thing that we do in our statements is state the given. Okay, so I'm going to rewrite what I just stated. Measurement angle B. Okay, and then right in here, that is our given information. Okay, so let's look at what we have to prove. It's saying we need to prove that angle A is congruent to angle C. So, if we know that measurement of angle A is equal to the measurement of angle B, and then the measurement of angle B is equal to the measurement of angle C, we also know this. We know that angle A is congruent to angle B, and angle B is congruent to angle C. So what we just did there, when we change that equal sign to a congruent sign, what this is using is our congruent definition. Okay, so definition of, I'm going to use abbreviations because I like using abbreviations. Congruent, I'm going to say angles, okay? Because that's what we're looking at, is angles. So definition of congruent angles, we can use this also in if we are changing a congruent symbol to an equal symbol, still using the definition of congruence there. Okay, so let's look at next step. We can, from this previous statement that angle A is congruent to angle B and angle B is congruent to angle C, remember this right here, our B's are the same, and we can cut out that middleman using that transitive property. We can go ahead and state angle A is congruent to angle C. And see that? That is our statement that we actually need to prove. And what we did to go from step 2 to step 3 is we used that transitive property. And we are done. Let's try the next one. Alright, similar to our last proof, except this time we are using segments instead of angles. We're going to show that DE, well, we're given this information that DE equals EF and EF equals DF. We're going to show that DF, segment DF is congruent to segment DE. So let's get started. We have our given information. Let's go ahead and write it. So DE is equal to EF, and EF is equal to DF, and that is given. Okay, step 2 here, we're going to change from the equal sign to congruent sign, because in our statement that we need to prove is that DF is congruent to DE. Okay, so we're proving things about segments. So just change the DE to segment DE is congruent to EF, and EF is congruent to DF. And that right there is, again, the definition of congruent, but this time instead of angles, we're going to say segments. All right, so step 3, again, we can use that transitive property and cut out this middle part right here that EF and EF are congruent. So we know DE and DF are congruent. Okay, and we can say that was the transitive property. Okay, well, that is almost the statement that we need to prove. It says DF is congruent to DE. Well, flip those around and we have the statement that we want. DF is congruent to DE. And when we flip things around, that is using the symmetric property. Okay, and that is it on this second proof. Let's go to another one. Okay, this is going to be our last proof for this session here. And what I'm going to do is show you this proof and then we'll stop for tonight. Okay, so it says in this one we're going to solve for x and explain each step for your reasoning. And this is what we're given. We are given this and this information in this diagram. So just about any time we have a diagram and it given information, we call those both given. Like whenever we go and say that this segment FG is equal to 5x minus 7, we can call that our given information, okay? So let's look at this. We are going to say step 1, write the given information. So FG is congruent to FJ, and then FJ is congruent to JH. That is given. Okay, from here, what we need to show that is FG and JH are congruent. And we can do that with the transitive property, because like here, FJ and FJ are in the middle. So we can say FG is congruent to JH, and that was our transitive property being used. Okay. Next, we can change our congruent symbol to an equal symbol by using the definition of congruent segments. So just say FG is equal to JH. That is definition of congruent segments. 4. Now substitute in what FG and JH are, which is this right here. FG is this, JH is this. So I'm going to say 5x minus 7 is equal to 3x minus 1. And just exactly what I said, substitute in those values for our f, g, and j, h. That's what I'm using, is this substitution property. Okay, step 5, we solve, because it says solve for x. So now solve. We can subtract a 3x from both sides. So using the subtraction property, we will get 2x minus 7 equals negative 1. So use the subtraction property of equality. And then I'm going to say, let's add that 7 to both sides to get 2x equals 6. Use the addition property of equality. And then last step, divide both sides by 2, and we get x equals 3. So our last step here was division property. And we are done with that proof. And we are actually done with this lesson, or part 1 of this lesson. So I'll see you next time in class. Goodbye, everybody.